Hey! Here we go. Alright, so we've got 4 objects going for 4 seconds. Velocity versus time graph shown. Rank the objects in terms of their displacement from highest to lowest. Put a greater than sign between 2 unequal displacements and an equal sign between 2 equal displacements. Then perform the same ranking, but the distances traveled by 4 objects. Alright, so we're looking for just total displacement. And we have these graphs here. Step 1, when given a graph, look at axes. What graph is this? Is it position versus time graph? Is it velocity versus time graph? Well, this one specifically is going to be a velocity versus time graph. So now we're going to think about the rules associated with this graph. We know of one rule so far, and that is the area under the curve. So this area right here for a velocity versus time graph is what? Well, what happens when you multiply the x-axis by the y-axis? Because remember, area is length times width. So if we have v times t, what physical quantity is that? That's our displacement, of course. So let's get to work. Alright, so we have 2 different sections here, and I don't know the area formula for this. My small, smooth brain can't handle that, but what I can do is put it into shapes that I do know. So I know this is 10 is my one side, and then this side is 2, so this area is 20, and then I'm just going to add it to this area. 2 times 5. 10. 30. Okay. Here, 5 times 4. This is 20. Uh-oh. Uh-oh. We drop down below the 0 axis, but that's okay. We already know we're going to do that, and we're going to do that. We're going to take this stuff here that's living in negative world to be negative. So we have negative 10 times 2, which is negative 20, because we're talking displacement, so direction matters. And then up here, we have positive 10 times 2, which is 20. So what's our displacement here? 0. We have not gone anywhere. We went backwards and then forwards, is what this is telling us. For object D, we're going straight backwards. Our displacement here is going to be negative 10 times 4 is going to be negative 40. Okay, so what does that mean in terms of displacement? So we have 4 lines here. We're going to have 4 different letters. Which one is the biggest? Negative 40, 20, or excuse me, negative 40, 0, 20, or 30? That's right. Object A is the most displacement. So A is greater than, what's the next one? 20. So that's B. Okay, anything equal that? No, that's a negative 20. So B is greater than C, and C is greater than D. There we go. If you're ever confused on what should I do, is it area under the curve or is it the slope that we're trying to pick out of here, just you can look at your units too. So the units for velocity are meters per second, and our time is just seconds. If you multiply those two, then seconds goes away, and we have just meters, and meters measures displacement. If we divide those two, meters divided by seconds, meters per second divided by seconds will give us meters per second squared. That's a unit we're not familiar with just yet, but it's acceleration. Alright, on to this next one where we're looking for just the distance. Alright, so the difference between displacement and distance is that displacement is a vector and distance is scalar, so we're just adding up all of our numbers. We don't care about the negative. So while this is negative 10 times 2, negative 20 would be our displacement, we're just going to call it a positive 20. This is positive 20. So this is now 40. This is negative 10 times 4. This is also 40. Positive because we don't care about direction when we're talking distance. Then we have velocity is 5 times 4 is 20. And then here we have 10 times 2 plus 2 times 5, 10. So we have 30. So that changes our rankings here. We can see that C and D are equal to each other. And then those two both are greater than A, which is also greater than B. That's it.